Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we are going to solve the 7th challenge in Ethernaut CTF, which is force. We're going to solve it using Foundry. So by watching this video and following these tutorials, you get two birds in one shot. You'll learn smart contract hacking, practical smart contract hacking, while learning the Foundry most common framework. Now, if you missed the first video in this series, how to get started with Ethernaut and the Hello Ethernaut challenge and how we set up the Foundry repo, definitely check it out because this is a prerequisite. There we set up the repository of Foundry, all the configuration, the environment variables, and everything that is needed to solve the challenges of Ethernaut using Foundry. I will leave a link in the description below. And if you are new here, my name is Johnny Time, an educator in the space of smart contract hacking, auditing, and security. And if you like this kind of content, make sure to subscribe and turn on the bell notification button. Now, without further ado, let's get started. Okay, so this is the fourth challenge, the 7th challenge in Ethernaut, and as you can see here, the description of the challenge is some contracts will simply not take your money. The goal for this level is to make the balance of the contract greater than 0. And here we have some things that might help, such as fallback methods. Sometimes the best way to attack a contract is with another contract. True. And we need to see the question mark page above beyond the console. So obviously we get some hints here that we need to deploy another contract in order to solve this challenge. We can go to the help section, but it's not necessary because I'm gonna show you everything that you need to know. So what does it mean? Force means that we're probably gonna force this contract to receive ETH, because as you know, in Solidity smart contracts, if we don't have a receive payable function, then they cannot, or any other function with a payable command or modifier or whatever, then the contract cannot receive ETH. Okay, it's blocked, it cannot receive ETH, but we have some exceptions where we can force contracts to receive ETH. But before we see how we can do it, first, as we usually do, I'm going to copy this smart contract to my local Foundry environment because we're going to solve it locally. And also in the meantime, I'm going to click here, get new instance. So the Ethernaut factory contract will deploy a new instance of the force challenge. And meanwhile the transaction is running, I will go to VS Code, to the SRC folder, create a new file, and I will call it force.sol. I'm going to paste the smart contract and basically just pasting the original contract from the exercise. Now in the script folder, we're gonna have our solution. And as we can see, we got new instance and we can already go to the console and copy its address. But now let's see how we can force this particular smart contract and basically force him to receive ETH. So how can we send ETH to a contract without a payable function? The solution is self-destruct. Self-destruct is our exception, and let's try to understand what it means. Self-destruct is an opcode that allows you to remove the bytecode, remove a smart contract bytecode from the blockchain, or simply just remove the contract from the blockchain. Now, it doesn't mean that you can use self-destruct to go to randomly contracts in the blockchain and destroy them, because this self-destruct needs to be in advance in the smart contract code. So if you're the one who wrote the smart contract, or you have some access control or special access to this contract, yeah, maybe you can execute this opcode, but it doesn't mean that you just can go around and destroy contracts. Now, the cool thing about this self-destruct opcode is that the first parameter that it gets actually one parameter, and this parameter is an address parameter where the destructed contract is going to send all the ETH from this destructed contract to this address. So when you use self-destruct, you're basically sending a parameter of an address, and this address is going to receive all the ETH. Doesn't matter if this address has payable function or doesn't have payable function, it will force him to receive the ETH and his balance will be changed, which is exactly what we need in order to solve this challenge and force the contract to receive ETH. So this is the smart contract, and our goal is basically to force him to receive ETH. So I'm going to go to the script folder and I'm just going to go to token, copy and paste just as a template. I'm going to change it instead of token solution to force solution. So we have our solution file. I can remove token solution. I don't need that. And yeah, so basically we're going to change it to 0.8 and we're going to change some stuff. Actually, I don't really need to import the first smart contract because it doesn't have any functions, any interfaces. I don't really need to interact with its functions. So I actually don't really need to import it or put the original contract. I just need to force send ETH to this address, to the instance address. By the way, if you're serious about smart contract hacking and you want to convert it into a career, smart contract auditing and security, you should definitely check out the complete smart contract hacking course that contains 30 different in-depth advanced chapters and more than 50 hands-on exercises that will make sure that you master the skill of smart contract hacking. We also have guest lectures with one of the best professionals from the industry, and upon completion of the course you also get a certification that will help you to land your first Web3 security job. You can see all the testimonials, all the success stories in the website, and the creme de la creme, you get also access to the best Web3 blockchain security Discord community, closed private community where you can meet people, hang out with them, learn, ask questions about the course or in general about smart contract hacking and auditing, maybe team up for auditing contests and evolve in this industry together with other people. To get a discount, check out the link in the description below. I'm going to change the contract name over here to a force solution. I actually don't need this line of code because I don't need an instance of the smart contract. I'm not going to interact with its functions. And let's remove these kind of lines of code here. And here we have the template of the solution. Now let's see how we can actually solve this contract. So as I mentioned in previous tutorial, here we are not going to actually create a new smart contract because Foundry just going to send transactions because it's a script file. So we need to create another contract that will be an intermediary contract, which we will destruct and transfer all its ETH to this force smart contract, basically to force it to receive ETH, because we cannot just send ETH from our EOA account to the contract because it will just simply reject it because it doesn't have any payable functions. So I will create a new contract and I will call it to be destructed. So this is the contract that we are going to destruct. We will use the self-destruct opcode, and right in the constructor, I'm going to receive the address that we want to forcefully send ETH after we destruct this exact contract. So it will be address payable and it will be force address. This will be the address of the challenge contract, right? The instance that we get from the Ethernaut website, and obviously the constructor need to be payable because we have to send ETH to this to be destructed contract in advance before we actually force it into the force contract. Now, all we have to do in this constructor is, or destructor, whatever you call it. So we'll just call the self-destruct function and we will pass it over here, this force address, the challenge contract address, and that's supposed to be it. Now, upon creation of this contract, it's gonna destruct himself and send all the ETH in his balance to this force address. And all we need to do in our script contract is just to deploy it and send one way. One way should be enough because one way is enough. So this force address will have one way. It's gonna be greater than 0, right? So I'm gonna do new to be destructed. And I'm going to send here value of one way. And here I will do payable. And now I need to paste the address of the smart contract that we need to forcefully send ETH to. So I will head over to Ethernaut, and we already created here a new instance by clicking get new instance. So I'll open the console and here we have the instance address. I can just copy it, paste it over here, and our solution file is ready. All we gotta do is now just execute it and see if it actually works. So in order to execute it, I will do forge script, and here it will be script, and then force. This is the script that you just wrote. And I will do -- broadcast so we can actually send the transaction using our MetaMask wallet to the Goerli blockchain, and click enter. The contracts will be compiled, and this is something that we covered also in previous videos. Because our script file has 2 contracts, we need to tell Foundry which contract we want to execute, which is this one. This is the script that we want to run for solution. So I will add this variable -- target contract and paste the contract name for solution. The transaction was sent and now we are waiting for receipt, which means that we're waiting for the Goerli validators to validate the transaction. Perfect, the transaction was submitted and confirmed. Now we can head over to the website, click here submit instance and see if we were able to achieve the required state, which means that this contract, this exact instance address has more than 0 ETH. Actually, it's supposed to have one way because we just forced him to receive one way through this self-destruct opcode. And we did it. Well done. You have completed this level and we have the next go to next level challenge, which means that we successfully completed the 7th Ethernaut challenge. Thank you so much for learning with me. And if you enjoyed this video, click this like button, subscribe to the channel and turn on the notification button for more amazing tutorials about smart contract hacking. I will see you in the next one. Bye bye.